This video will show you how to add, subtract, and multiply polynomials. The sum or difference of two or more polynomials can be found by combining like terms, but you add only the coefficients of like terms. Do not add the exponents. So when you look at a problem like this, you have a couple options. You might be able to just combine these like terms in your head. You might want to rewrite the problem horizontally so that you put your like terms next to each other. So x squared plus 3x squared, then minus 2x plus 4x plus 1 plus 5. Now that you have your like terms next to each other, combine. Of course, you know that x squared is the same as 1x squared. Add this together gives you 4x squared. Notice the exponent does not change, just the coefficients. Negative 2x plus 4x is a positive 2x, and 1 plus 5 is 6. So that's one way to go, and that is to rewrite like terms next to each other and then do your combining of like terms. Another option is to set it up vertically. This might be a little less writing. This is still adding, so these like terms I'm going to pile up vertically. I'm going to put the negative 2x squared underneath the 3x squared, the negative 4x underneath the negative 7x, and negative 11 under the 9. Draw a line just like old-fashioned addition and combine my like terms in a vertical format. 3x squared minus 2x squared is 1x squared. Negative 7x minus 4x is negative 11x. And 9 minus 11 is negative 2. Of course, this 1 right here is not necessary. It should just be x squared minus 11x minus 2. So both of those were addition problems. You can string them out horizontally like I did on the first example, or you can line them up vertically, or if you're good, you can just do it in your head. Subtraction is the same idea, but you've got to be careful about this minus in front of this parentheses. You have two ways to think about this. Some people teach put a little 1 right here and then distribute a negative 1 through the parentheses. That's an option. Another way to do it, and this is the way I think about it, I look at that minus right there and it just tells me to change the signs. But I've got to change all the signs in that parentheses. So I can string this out horizontally. I can have x squared plus 12x minus 23. Changing all of these signs. Used to be a positive 2x squared, so now it is negative. Used to be a positive 7x, now it is negative. Used to be a negative 20, now it is positive. And then three choices. Can you put these together in your head? Do you want to rewrite so that the like terms are next to each other? Or do you want to put this under vertically? I'm going to do this one horizontally. So x squared minus 2x squared plus 12x minus 7x minus 23 plus 20. So now I have all my like terms together. I just have to do the arithmetic. You know there's 1 right here. 1x squared minus 2x squared is negative 1x squared, but more simply it's just negative x squared. 12x minus 7x is 5x, and a negative 23 plus 20 is a negative 3. I could have thought about this as negative 1 and then multiplied. Negative 1 times 2 is what gives me the negative 2. Negative 1 times 7 is what makes the negative 7. Negative 1 times negative 20 is what makes the positive 20. This one I'm going to combine with the vertical format. This minus here I know is going to change all of those signs. So this 6x squared is now going to be a negative 6x squared, and I'm going to put it underneath the 3x squared. This saves me having to do a lot of rewriting. This negative 9x needs to become positive 9x, and I will line it up right here. And the negative 10 becomes a positive 10. Line it up underneath the negative 9. Now combine your like terms this way. 3x squared minus 6x squared is negative 3x squared. Negative 4x plus 9x is positive 5x. And negative 9 plus 10 is positive 1. So that's the addition and subtraction story. Pretty easy. You're just combining like terms. Multiplying is a little more complicated, but not difficult at all. Multiplying these polynomials, let's start with just a monomial times a monomial. And all this is using your exponent laws, which is keep the base and add the exponents. So x to the 4th times x squared is x to the 6th. Remember, there's an understood exponent of 1 right there. So when I do y to the 5th times y to the 1st, it also gives me y to the 6th. So that's just your exponent law for a monomial times a monomial. If you want to do a monomial times a binomial or trinomial, whatever, you are putting together two skills you already have. One is distributive property, so I'm going to have to multiply 3x squared times all of this. And then as I do that multiplying, I'm using the exponent law. So 3x squared times 4x squared is 12, x to the fourth. 3x squared times 5x is a positive 15x cubed. And 3x squared times negative 1 is negative 3x squared. Same kind of problem here. Multiply 5x cubed times 2x squared is 10x to the fifth. 5x cubed times this is negative 35x to the fourth. And 5x cubed times this is negative 50x cubed. So that is a monomial times some sort of polynomial distributive property, and then just use your exponent laws. This leads us to a binomial times a binomial, which most of you know as FOIL. Basically, FOIL is just distributing twice. That's the way we really do this, is distribute the 3x through here. So 3x times 2x is 6x squared. 3x times 7 is 21x. Then I'm going to distribute using the negative 5. Negative 5 times 2x is negative 10x, and negative 5 times 7 is negative 35. But this is where the FOIL came from. When I did 3x times 2x, that was the first times the first. The 3x times the 7, that's considered the outer because 3x and 7 are both on the outsides. The negative 5 times the 2x, that's the inner because those are close to each other. And the last thing I did was negative 5 times 7, and that truly is the last because it's the last thing in this parenthesis times the last thing in that parenthesis. 99% of the time after you FOIL, you're going to have some like terms in the middle. So we have 6x squared. 21x minus 10x is positive 11x minus 35. Notice again, when I got this 6x squared, I'm using the exponent law. 3x times 2x, keep the base, and add the exponents. 1 plus 1 is 2. But I did not do anything to the exponents here. Here I am subtracting, and when you subtract, you only deal with the coefficients. The next one is also a FOIL problem. It may have some other powers, but that's okay. It is still FOIL. X squared times x squared is x to the fourth. X squared times 5y squared is positive 5x squared y squared. Distribute the negative 6y squared. We have negative 6x squared y squared. And then negative 30y to the fourth. That comes from this times the 5. These are like terms in the middle. So this is x to the fourth minus x squared y squared minus 30y to the fourth. X plus 8 times x minus 8. Let's FOIL that out. X times x is x squared. X times negative 8 is negative 8x. 8 times x is positive 8x. And negative 8 times negative 8 is negative 64. Notice in here what happens. Negative 8x plus 8x cancels out. And all we get is x squared minus 64. Now, did you know that was going to happen beforehand? You might have if you remember your Algebra 1. This is a very special setup. We have the same x in the front of both parentheses. We have 8 in the back of both parentheses, but we have a positive and we have a negative. Whenever you have that kind of setup, the middle stuff, the O and the I of the FOIL will always cancel out. So all you really have to do on this kind of setup, notice it's got to be same things in the parentheses, but one time you have a plus, one time you have a minus. I can just do 3x times 3x, which is 9x squared, and then I can just do the backs. 5 times negative 5 is negative 25. No reason to do the O and the I setup because they're going to cancel out. This is a very special setup, and it's called the difference of two squares. The reason it's called the difference of two squares is because that's what it turns into. It is a minus between two perfect squares. Now, don't get that confused with this setup. This is 2x minus 5 in parentheses squared, and the only way to do this is to write this out twice. 2x quantity squared means 2x minus 5 times 2x minus 5. And once you do that, all you have to do is FOIL. 2x times 2x is 4x squared minus 10x minus another 10x plus 25 because it's a negative times a negative. These two do not cancel out because they are both negative. This is 4x squared minus 20x plus 25. Same setup here. Even though there's an extra power inside here, I still need to write this out as x cubed minus 5 times x cubed minus 5. And notice when you write this out twice, you are writing out this thing twice. Don't put a plus and a minus. It's the same sign twice. Distribute. X cubed times x cubed is x to the 6 because we are keeping the base and adding the exponents. X cubed times negative 5 is negative 5x cubed. Negative 5 times that x cubed is another negative 5x cubed. And that is not a coincidence. Anytime you are squaring a binomial like this, you will get the same middle term twice. And then plus 25. We've got some like terms right here. X to the 6 minus 10x cubed plus 25. So when you have to square a binomial, what you want to do is write out the binomial twice and then just use your FOIL. The trinomial you get is called a perfect square trinomial. This is a strange little problem that looks like it could be difficult, but it really is not if you follow order of operations. Order of operations says do what's inside the parentheses first. I look inside here and I realize that x plus 3 that's in the parentheses does not need to be in parentheses. So I could just write this out like this. Well, 3 minus 7, those are like terms. And this is just x minus 4 squared. Here we finish up like we just did a minute ago. X minus 4 times x minus 4. FOIL this out is x squared minus 4x minus another 4x. Negative 4 times negative 4 is a positive 16. Combine your like terms is x squared minus 8x plus 16. So that kind of problem really is not as ugly as you might have thought it was. Brings us to binomial times a trinomial. There is no cutesy little word, but it's just a matter of distributing. So I need to multiply 2x times all of those using my exponent laws. 2x times 3x squared is 6x cubed. 2x times negative 4x is negative 8x squared. 2x times negative 2 is negative 4x. Then I need to distribute with my 5. So 5 times 3x squared is 15x squared. Instead of writing it out here, I'm going to put it under here like I did with the vertical adding and subtracting, because now I've got my like terms lined up. 5 times negative 4x is negative 20x being lined up right here. 5 times negative 2 is negative 10, just strung out to the side there because there's nothing to group it up with. Then combine your like terms in the column. 6x cubed plus 7x squared minus 24x minus 10. Same kind of problem, still distributing. The 2x times all of this stuff. 2x times 3x squared is 6x cubed. 2x times 2x is 4x squared. And 2x times negative 8 is negative 16x. That's just using your exponent laws. And then let's distribute with the negative 7. Negative 7 times 3x squared is negative 21x squared. Negative 7 times 2x is negative 14x. And negative 7 times negative 8 is positive 56. Combine 6x cubed minus 17x squared minus 30x plus 56. So that's your adding, subtracting, and multiplying of polynomials.